Hello and welcome to this ESPRIT TNG release 3.4 preview. We will show today three important improvements in the 3-axis. Stock sensibility in roughing, surface accuracy in parallel plane finishing, rounding toolpath edge in global finishing. So, stock sensibility in roughing. For the roughing cycle, we often want to avoid toolpath passes that don't cut a consistent volume of stock, particularly when we apply it in roughing remachining. The parameter minimum material thickness in the toolpath stub was introduced right to avoid those passes in the areas where the stock has a thickness smaller than the parameter value. So it is a sort of sensibility in respect of the stock. But as the help explained, till today such sensibility had no effect in vertical walls, and passes on them are not avoided even when the stock left over them is smaller respect the value set for minimal material thickness. So thanks to this new improvement, now the stock sensibility in roughing will be the same along all the part independently from local slopes. So let's see this inside the spree. Okay, so here we are inside the spree and we have this part. It's a simple open pocket. This is the toolpath we got from the previous release of the spree. So first, I want to show you the stock that preliminarily we have on this part. So we can see that along all the vertical wall, we have 1 millimeter of stock. Then on the bottom, here on the left, we have 6 millimeter over the bottom. Here in the center we have this area where we have just 1 millimeter, and then in the right 0 millimeters, so no stock. So as I told you, this was the toolpaths previously respect the introduction of the new feature to avoid the toolpaths on this vertical, and you can see that we have toolpaths along all the vertical wall. Now if we go inside the roughing parameters, we can see that here we had a program value of minimal material thickness, also we could call also sensibility to stock, of 1.2 millimeter. So the question is, why along this wall we have 1 millimeter, where we have 1 millimeter of stock, and we ask the system to avoid the area having a minimal material thickness above 1.2 millimeter, and we are still having passes. So this was a limitation of a previous version, which has been now improved. So if I just rebuild the operation, I get this new toolpath, where you see that all the toolpaths along the vertical walls has been eliminated as we wanted, and also all the toolpaths along this bottom area here, where we only have 1 millimeter of stock while our sensibility is 1.2, there is no toolpaths. And so the toolpaths got concentrated only in this left area, and Why we have this toolpath here on the vertical wall of the left area? Well, this is absolutely correct, because if you think we could machine immediately the bottom without previously having these passes above, we should surely have an overload of a tool engagement, and so it should have not correct. So let's pass to the next improvement. Next improvement we will talk today is surface accuracy in parallel plane finishing. In toolpath's calculation, the system considers a triangulated representation of a part. The triangulation is function of a free-form geometry tolerance parameters. So the triangulation is an approximated representation of a part to be machined. In most cases, this approximation is acceptable, but there are special cases, particularly in the automotive field, where an extremely accurate finishing is needed. We have now realized a new method for which the toolpath is calculated based on the analytical form of faces of a part, and not on its triangulated representation. Before introducing it, we have effectively tested it cutting real automotive molds, getting better surface quality results respect to the traditional methods based on the triangulation. In this first phase, we introduce the option to activate the new method only in the parallel planes finishing cycle. But in the future, we will extend its uses also to other finishing cycles. The new method has been introduced as an option because it leads to longer calculation time respect to the traditional methods. So let's see this inside ESPRIT. So we are inside ESPRIT now, and I have this part. This is a very simple part. This new surface accuracy is something hard to demonstrate now in the demonstration right in front of a PC video. Why? Because its benefit is right on the surface quality of the real part. It's hard to see on a PC video. But anyway, I made this kind of experiment here. So this cylinder here and this part here has been tessellated very roughly, and I can show you if I go inside File, Option, Machining. You can see here this value here. So this is very rough, because the default value is 0.005 millimeters. So this is extremely rough. So triangles are let's say distant respect, in this case as distant respect to the analytical surface. In terms of result of toolpaths, I can see here, if I run an analysis toolpath and I show this. So if you notice here, this is very weird behavior, and absolutely it is not good when you run this program in the machine, because you have couple of points very near, followed by singular points. Also the distance doesn't seem even at a glance. So for sure, cutting this part with this toolpath, the result in terms of surface quality will be bad. So let's go inside the cycle parameters and And let's notice that we have this new parameter, surface accuracy. So first of all, what is its default? Its default, let's see. So its default is no. Why? Because surface accuracy is very nice, but takes longer calculation time. So we want to avoid this longer calculation time, which can be consistent. And also because this is something you will not need in every situation, because till today the system has proven to cut good quality parts without this new option. This is something that you should really activate in special case when it's really reaching, you're really reaching the really best quality of the surface cutting. So let's try what happens now allowing this surface accuracy. Let's recalculate. Nothing changed. The tolerance remains exactly the same, which is the default machine tolerance. And let's reanalyze the toolpaths. So this is very nice because the space is even. I have eliminated the double points, and of course there is something I cannot see, which is the position of the tool positioning, which is absolutely, let's say, mathematically precise, analytically precise. Things that was not true in the previous toolpaths, because the tools was shutting on a triangulated, approximated model. So this is something very interesting that I recommend you to use when you really need it, when you are really looking for the absolute good quality, good surface cutting quality. So let's move to our next topic of today. Next topic today is rounding of sharp edge in global finishing concentric toolpath. Last year, 2016, with R2.2, we released the new 3-axis global finishing cycle. The part is logically divided in steep and shallow areas. The system applies a Z-level toolpath to the first and a concentric toolpath to the second. One of the first feedback from the field has been that for the concentric toolpath, internal edges in the trajectory should have been rounded to allow real ASC behavior, high-speed cutting. The new rounding parameter is now available right for this. So let's see this inside ESPRIT. Okay, so we are inside ESPRIT and we have this part, which is actually the bottom of the plastic bottle, and this is a toolpath calculated from a global finishing cycle, where you can see that we have all this kind of sharp edge, which are not good for high-speed cutting. So we have to avoid them. Now, if we open our cycle and we are in Toolpaths tab, and we have this new rounding parameter. First of all, let's see which is its default. So now its system default is yes, because we absolutely want by default to create a HSP high-speed cutting toolpaths. And so this was just no, because I really wanted to show you the difference. So let's validate and let's recalculate this toolpath. So for this part, the toolpath created is only concentrical because I put in the parameters the threshold slope to 90 degrees. This means that all the toolpaths is completely concentrical. And here, magic, the toolpath is completely rounded where before was sharp edges. So this is all for today, and thank you for watching this. Bye bye.